Hello everyone, this is the lecture series of hydraulic machine subject, and in this subject the course code is ME1317 and unit number 5th, lecture number 35. This is the last unit of this lecture series. So today I will discuss about the topic regarding hydraulic lift and hydraulic intensifier. So for my introduction, myself Rahul Kumar, Assistant Professor, Department of Mechanical Engineering, Suresh Gyan Vihar University, Jaipur. So today I will discuss about the topic regarding hydraulic lift and intensifier and its advantage, disadvantage, working principle, and this is a totally theoretical topic, and working principle and some industrial application, right? And for the case of hydraulic lift, this is a device for moving object using force created by the pressure on a liquid inside the cylinder. But in the case of intensifier used to raise the pressure inside the fluid line, right? And here the incompressible oil is pumped into the cylinder, and which forces the piston upward. For the case of incompressible oil, because if oil is compressible, so this cannot provide a good effect inside these fluid lines, and also the hydraulic cylinder, right? Then go to the next objective of this topic. So both of the objective of the topic based on the different points. So by the end of this section, you should be able to understand about the, so all are the topic, both are the two topics. These are the applications of the Pascal's law. So here the principle of the hydraulic lift is based on the Pascal's law for generating force or motion. So you should be able to understand about the basic application of the Pascal's law, and Pascal's law states the intensity of the pressure in a static fluid is transmitted equally in all directions, and this machine can be used for any kind of material and eligible for various pressing technology like bending, forging, or other things, and greater versatility. Here are the few examples of the machine you also learn here. So this is very important topic. For the case of intensifier, so in the case of intensifier, you should understand the how does the intensifier work, and this is a pressure increasing the device inside these fluid lines. So this device carries with no any moving parts, only some arrangement of the cylinder, and it can provide a pressure rise, right? For the introduction, so for the introduction of the hydraulic lift, the concept of this and its application to hydraulics can be based on the Pascal's law. So this is a example. Below here a small amount of force is applied to an incompressible liquid on the left to create a large amount of force on the right. So one of the most important equipment used in transporting goods and the people is the hydraulic lift. So this lift is not a very lengthy, but it provides a 1 or 2 storage space, and by the way of hydraulics, such lifts are able to carry heavy loads with great ease and lift is vertically. So hydraulic lift come in the form of passenger lift, service lifts, and to carry goods to higher floor, etc. So hydraulic elevator system lift a car using hydraulic ram. So some manufacturing unit or some overhauling unit, like as a inside the car wash company or any other thing which uses the hydraulic elevator system, right? A fluid driven piston mounted inside a cylinder, and all the weight of the elevator cab is supported on the piston only. So for this case, the cylinder is connected to a fluid pumping system, and typically hydraulic system like this use oil, but other incompressible fluid would also work here. So if I'm talking about this principle, so it based on the principle of the hydraulic lift, on the principle of Pascal's law. So Pascal's law for generating force or motion, which states that pressure change on an incompressible liquid in an confined space is passed equally throughout the liquid in all directions. So these are the different types of approaches for this hydraulic lift. And for the use of the hydraulic system or for precision control, a large force application are required, so are economical and make excellent use of the resources. So hydraulic system works by applying force at one point to an incompressible liquid, which send force to a second point. The process involves two pistons that are connected by a oil-filled pipe. The image below in a representation shows the hydraulic lift. Write this. So here just like a one crane type of lift. So it is used for moving the person from one floor to any other floor, right? And this is a cage type of lift. This is a cage type of lift. Here this shows the top floor, this is the second floor, and this is the first floor, and here is ground floor, and this is a sliding ram is present here. This is a fixed cylinder and fluid under pressure inside it, right? So but this type of lift carry very large amount of reservoir tanks and all assemblies. So this diagram represents the a simple version of the working mechanism of hydraulic device, and the handle on right, and it handle the different types of persons which you want to send the first floor, second floor, or third floor or top floor. This is depend on your choice, or this is depend on the person's choice. And next thing is here working. So this is a working is very simple, because here fluid rises. Suppose in this figure, just you see here, this is a one simulator's figure. One shows the cylinder. This is a cylinder body, in which cylinder piston is reciprocate. In which cylinder piston is reciprocate, and this and for the case of two piston, so piston is directly connected to the this lift, directly connected to the lift, and in the lift to carry the passenger and goods, all things, right? Third number is the fluid reservoir. Fourth is rotary pump. Third is wrong indication here. Fourth is rotary pump. Fifth is valve, and sixth is hydraulic fluid. This is the hydraulic fluid. So this works on the force generated in a cylinder system. Force generated in a cylinder system depend on the size of the piston. If the smaller of the two pistons in 2 inches, then large force is the 6 inches, or 3 times or large. The amount of force created with the 9 times greater than the amount of force from the smaller piston. So In this diagram, just you see the working principle of this. Working principle of the hydraulic lift. So here the main component is, this is the pump. Pump is just like as a heart of the system, and this send the fluid at the pressurization time and pressurize this fluid, and this creates a force. This creates a force. For this force, this piston moves the upside. This piston moves the upside, and if you want to lift in down, going downside, then this valve is open. Only this valve is open. Then this fluid goes from this line to the reservoir, right? So this is the simple working of this hydraulic lift. And the pump, suppose in the case of working, so this is the pump forces fluid from the tank into a pipe leading to the cylinder. Suppose this is a tank, this is a hydraulic pump, a rotary pump are used here. And next is this and the fluid, send the fluid inside these fluid lines. Then the valve is opened. The pressurized fluid will take a path at least resistance and return to the fluid reservoir. But when the valve is closed, suppose this is the valve of the cylinder, this is the valve of this system, and this valve is first time this valve is open, then fluid just goes here and then return to the reservoir, and this valve is closed, then this fluid goes to the inside the cylinder body and then pressurized, right? But when the valve is closed, the pressurized fluid has now where to go except into the cylinder. As the fluid collects in the cylinder, it pushes the piston up and lifting the elevator car. And when the car approaches to the correct floor, the control system sends a signal to the electric motor to gradually shut off the pump. And the pump forces fluid shut off to the pump here. And these are the two types of lift. First one is direct acting hydraulic lift, and second is suspended hydraulic. These lifts have two types. First one is direct acting hydraulic lift and second is suspended hydraulic lift. So just you see, here is a one figure which shows this figure shows the suspended hydraulic lift. This shows the suspended hydraulic lift, and this one figure shows this is the direct acting lift and this is the suspended hydraulic lift. For the case of parts of the hydraulic system, the purpose of the hydraulic system is widely vary, but the principle of how hydraulic system work and their components remain the same for all parts. So this figure 1 shows the direct acting hydraulic lift. For this lift, here the capacity is 500 kg to 2 ton, and fork length is here 1150 mm as per requirement, and fork width is 600 mm as per the requirement. And this is the second is suspended hydraulic lift, and this is the 1800 mm and 18 meters and can carry a load weight of 500 kg to 1500 kg, right? So this is the different types of two types of lift. So the first is here direct acting hydraulic lift. So the system consists of a ram which slides inside the fixed cylinder, and the cylinder has suitable opening at the bottom of the hydraulic lift, and hydraulic fluid to enter and also suitably designed to allow the ram to slide up and down. And here ram is attached to the top of the car, which act as a capsule carrying people or goods, and the ram is pushed by the pressure of the fluid acting beneath. And thus for this cage then moves the various floors. This is the cage. This is a cage which move the various place which you want to send this person or goods, and this is based on your need, right? And the cage is moved in downward direction by allowing oil to get drained from the cylinder back to the oil reservoir. So this guides rail are required to guide the ram in vertical plane. Car speed up to 125 feet per minute. So this is a 38.1 meter per minute is attained, and maximum travel length is 12 feet, 3.6 meter for this case. And in this case, cage type of lift means direct acting hydraulic lift. It has cage, and on which people can stand. Cage is a device where the people can stand over it, right? So cage is a device which holds the goods and persons, and which is suspended from a wire cable or some jigger consisting of a fixed cylinder, a sliding ram, and sometimes it is used as set of two police blocks. And which is provided at the foot of the hole of the cage, and one pulley block is movable while the other one is fixed, and the sliding ram end is connected to the movable pulley block, and the cage is suspended from the other end of the rope. And this is the one construction of this, like this, right? So the time for which the valve is kept open decided by the electromagnetic switch, which gets signal from the people who use the lift, right? So this is a totally automatic manually operation, automatic, or sometimes it may be fully automatic, sometimes it may be manually operated. This is depend on the different types of working fluid. And the second lift is here, suspended hydraulic lift. This is the suspended hydraulic lift is here. It has a cage. So this is the case of the suspended hydraulic lift. In this hydraulic lift, this is the ground floor, first floor, and the second floor. Here one piston cylinder is here, where the piston is reciprocated. In this piston cylinder, one rope is connected, and this rope is connected to the movable pulley block. So here is sliding ram is here. So if you want to shift the ram from ground to first floor, then you apply the liquid under the pressure from here, and then if this system is retract, then it straight the pulley, this pulleys, and for this case this lift goes on down to upper side, and if you want to this lift send to downside, then just you stop this here, and this liquid sent to the reservoir. At this condition, this piston is moved backward side, and that time this lift goes up to downside, right? So this is the operation of this lift is here. Similar in this case, one arrangement is given, and this provides the different types of lift operations. So it has cage. Here is also a cage is attached, but which is suspended from the wire cable and the jigger, and consisted of a fixed cylinder, a sliding ram, and a set of two police blocks, which is provided at a foot of the hole of the cage. One pulley block is movable, while other one is fixed. The sliding ram end is connected to the movable pulley block. The cage is suspended from the other end of the rope, and the rising or lowering of the cage of the lift is done by the jigger. And this arrangement is used to increase the speed of the lift by a 2:1 roping ratio, and car speed up to 150 feet per minute is attained, and maximum travel length is 48 feet, or we can say that 14 meter. For the working of this here, water or any hydraulic fluid at a high pressure is admitted into the fixed cylinder of the jigger. Suppose this is the jigger construction, right? And this high pressure hydraulic fluid pushes the sliding ram to move towards the left side. Suppose at this condition, this ram or sliding ram or the piston is moved from the right to left side, and next case, when it moves, the distance between the fixed and movable pulleys increases, and thus the cage is lifted up. In this case, cage is lifted up when the water or hydraulic fluid under high pressure inside the cylinder is released. Then the distance between the two pulleys are decreases, and thus the cage comes down. Thus, the suspended type of hydraulic lift are more popular than direct type lift. Beside the above basic arrangement, hydraulic elevator can also be installed with more than one cylinder, and on some of the hydraulic piston, plunger consists of telescoping concentric tube, allowing a shallow tube to contain the mechanism below the lowest floor. On some, the hydraulic pressure plunger consists of a telescopic concentric tube, allowing a shallow tube to contain the mechanism below the lowering floor. On other, the piston requires a deeper hole below the bottom landing, usually with a PVC casing for protection, and also known as caisson. So this is the operation of the one thing is here, suspended hydraulic lift. So we go to the hydraulic elevator. So the hydraulic elevator operate at the slower speed and serve up to a 14 meter of travel. These are recommended for light usage, low height installation, benefits, lower ownership cost, quick installation, and does not need to penthouse or overhead support to house the machinery, and flexibility in the location of the motor room, and upon power failure the lift is lower to the ground floor and releases the door, right? So this is the benefit of this lift, and this lift cannot start at any place, right? Stuck at any place. And drawback is here, this is very noisy, slow and poor ride quality, and high on energy consumption, and may cause potential environmental damage from leakage of hydraulic fluid, right? Then these are the some lift used for the hospital purpose, and this is lift used for the car lifting purpose, right? And these are the applications of the hydraulic lift. So these are the different types of application. Just one is wheelchair lift, industrial hydraulic application, and material handling truck trailer. Material handling truck trailer. These are the best applications of the hydraulic lift. So here are the two applications. One is hospital lift and second one is car lift. Is used to send the first ground to upper floor, right? So now comes to the next topic is here hydraulic intensifier. And next thing is here intensifier. So the hydraulic intensifier is a mechanical device which is used to increase the intensity of pressure of fluid, and it utilizes the energy of large quantity of liquid at low pressure. Some hydraulic mechanics requires high pressure for low working, but this high pressure cannot be obtained by using pump. So for this purpose, some of these hydraulic machines are hydraulic press, hydraulic ram, and the hydraulic lift, etc. These machines requires high pressure for this operation to obtain the required amount of pressure. A hydraulic intensifier is mounted in between the pump and the working machine. This is the working in between pump and the working machine. So it produces the low pressure at the input and it gives the output as a high pressure liquid. High pressure liquid. So it is a device used for producing high pressure liquid by using the energy of larger amount of liquid at low pressure. So it has two types. One is the single acting and other one is double acting. Here we'll discuss the only single acting hydraulic intensifier. That is, it supplies high pressure liquid during the downward stroke only. The hydraulic reservoir for the case of double acting hydraulic intensifier supplies high pressure in both strokes, that is in continuous manner. Just you go to the next page. So these are the some components. First is fixed ram, sliding cylinder or ram, fixed cylinder, and the valves. These are the some main component, and the some other component. First is the function and then construction. So the hydraulic intensifier for the construction case, the hydraulic intensifier, it is very simple in construction and it has only three main parts, and these parts are attached in proper sequence for increasing the pressure of input fluid, and these three main parts are fixed ram, sliding cylinder, or ram and fixed cylinder. And the main function of this hydraulic intensifier is it is used to increase the intensity of pressure of liquid by energy available from a large quantity of water at a low pressure. For the construction case, it consists of a fixed ram. For the fixed ram, this is a innermost and the smallest part of the hydraulic intensifier, and it is surrounded by the sliding cylinder, and the high pressure liquid is supplied to the machine through this fixed ram, and this fixed ram is surrounded by a sliding cylinder which is itself surrounded by a large fixed cylinder as shown in figure. So just you seen in figure, this is the figure of the hydraulic cylinder or hydraulic intensifier, or this is a single acting hydraulic intensifier. For this is here low pressure liquid from supply and it gives a high pressure liquid to machine, right? This is the fixed ram. Here is sliding ram of the cylinder, and this is one more low pressure liquid, and here is two exhaust, and this is the low pressure liquid from supply. So this is a case of hydraulic intensifier. So the sliding cylinder contains water at high pressure, and which is supplied to machine through fixed ram. The large fixed cylinder contains water from the main supply at a low pressure. So for this case, hydraulic intensifier, right? So the working of this hydraulic intensifier, a large quantity of water at a low pressure from a supply enters the large fixed cylinder through a valve D. Same time, the sliding cylinder lies at the bottom of the stroke and the valve D and B are closed and valve A is opened. Hence, low pressure liquid from the supply enters to the sliding cylinder through valve A, and valve C is opened, from which allows the low pressure liquid from the fixed large cylinder to the discharge to the exhaust. Suppose this is the exhaust for this case, and therefore sliding cylinder moves upward. When sliding cylinder reaches its topmost position, the inside space of the sliding cylinder is full of low pressure liquid. Then valve A and C are closed and valve B and D are open. For this case, the low pressure liquid from the supply and enters the large fixed cylinder and forces the sliding cylinder to move downward. Hence, the pressure of the liquid inside the sliding cylinder is increased and high pressure liquid is supplied to the hydraulic machine. So, for the calculation of this, if we are going to the calculation, let P1, this is the intensity of pressure at the low pressure liquid, and P2, this is the intensity of pressure at the high pressure liquid. So A1 and A2, these are the cross-sectional area of the sliding cylinder. This is given by the A1 equal to pi by 4 D1 square. So A2 is the cross-sectional area of fixed ram. This is equal to pi by 4 D2 square. So D1 equal to outer diameter of sliding cylinder and D2 is the outer diameter of a fixed ram. So these are the some calculation about this notation point. And then calculation to force exerted by a low pressure liquid on the sliding cylinder in downward direction. This is the F1 equal to P1 into A1, and force exerted by the high pressure liquid on the sliding cylinder in upward direction. This is the F2 equal to P2 A2, and equating the upward and downward forces, this is a P1 A1 equal to P2 A2, and intensity of high pressure liquid, this is a P2 equal to P1 A1 divided by A2. This is a P2 equal to P1 into D1 by D2 square, right? So if you find the pressure at the outlet side, so P2 equal to P1 into D1 by D2 ka whole square. This is depend on the inlet and outlet diameter of the pipe. So these are the some applications of this hydraulic intensifier. For this application, air operated hydraulic intensifier are used commonly for clamping, holding, punching, presses, jack, torque, wrenches and more used, and it is used in hydraulic press, crane and lift also. Lift which required liquid at very high pressure, and the high pressure cannot be obtained from many supply directly, and it is located between the pump and the hydraulic machine. And some more application like this, hydraulic intensifier is used to supply high intensity pressure wherever you need, and it is used where pump is not sufficient to provide high intensity pressure as per the requirement, and it is most commonly used in hydraulic pressure, hydraulic ram, hydraulic cranes and hydraulic lift, etc., where high intensity of pressure required for lift the load. So these are the different kinds of advantages. For the advantages, so hydraulic intensifier, it is a compact device and it is used for very easy to operate and control, and it can be directly attached with a hydraulic machinery and wherever it is needed, and it is compact as well as energy saving device. It is a compact as well as in a energy saving device, and it is the cheaper device if we look about its working, and it save lot of money by their easy and economical operation. We can say that it is a simple in working, safe and economical in operation. So it has high speed operation. Due to this, it can be easily start and stop as per our requirement. So it can easily works with the pumps, that why it may be attached in between the pump and the hydraulic machinery, and in last case it is very easy to operate and control, and it's provide constant force and pressure in whole working process, and okay. And for the disadvantage case, so the main disadvantage of the hydraulic intensifier is same which most occurs in case of the all other hydraulic systems, that is leakage of the fluid, and it provide a very high noise sometimes, and the system requires high maintenance. The other main disadvantage is of leakage. Fluid can catch fire, so the working should be done in proper manner and try to avoid the any small leakage of the fluid. And sometimes the hydraulic fluid used in may be corrosive, which damage the out of machinery. And for the case of the hydraulic intensifier, this is all about the hydraulic intensifier. If you have any query regarding this lecture, then you go through the references and gain more knowledge about this topic. And so we will move to the next section of this lecture. This is the MCQ question section. So we will move to the MCQ sections. So these are the MCQ problems. This is the here in MCQ problems, here 10 questions are given in this series. So these questions related to the this topic, hydraulic ram and the hydraulic lift and the hydraulic intensifier case. So first question is here. A is a hydraulic machine for converting hydraulic power at low pressure into a reduced volume at higher pressure. So here 4 option is given. First one is hydraulic ram, hydraulic crane, C is the hydraulic intensifier, and D is the hydraulic accumulator. So for the explanation about this question, a hydraulic intensifier is a hydraulic machine for converting hydraulic power at low pressure into a reduced volume at high pressure. So the working volume of the intensifier is limited of the stroke of the piston. This is turn limit to the amount of work that may be done by one stroke of the intensifier. So the correct answer is here hydraulic intensifier is the correct answer for this question. And move to the second question. If the diameter of the two pistons used, the arrangement are different, the blank space in each cylinder will vary. So in the first case, option A is here hydraulic velocities, B is here hydraulic acceleration, C hydraulic pressure, D hydraulic force. So the correct answer is here. What is this? So if the diameter of the two pistons used in arrangement are different, the hydraulic pressure in each cylinder will vary. So the hydraulic pressure in both the cylinder will change in the same ratio as their areas. The smaller piston will give rise to the higher pressure. So if means it applies the pressure at the all directions, so force is difference. So they here arrangement are different, then the hydraulic pressure in each cylinder will vary. So option C is right for this case. Then we move to the next question, question number 3. The working volume of the intensifier is restricted by the stroke of the piston, shaft, C option is jack, and D is cylinder. So the correct answer is here piston. So the working volume of the intensifier is restricted by the stroke of the piston. So piston, A option is right answer. As a result of this amount of the work that may be done by one stroke of the intensifier is controlled. There are no reciprocating machines, right? There are not a reciprocating machine. And then move to the question number 4 also. So the question number 4, intensifier are employed as a part of the machines such as hydraulic presses, hydraulic crane, hydraulic accumulator, and hydraulic ram. So correct answer is here hydraulic presses, right? Next question. In hydraulic press, the metal can be pressed, straightened, molded, presses, straightened, and molded. So in hydraulic press, here D option is right, because of the hydraulic press provide the all operation pressing, straight, and the molded operation. And then next is here 6th question. A small intensifier usually A in their basic system. So 4 option is given: stepped piston, stepped cylinder, accumulator, and stepped presses. So the small intensifier usually have a constructed with the stepped piston. Stepped piston, it is usually a double-ended piston, and it consists of 2 unique and diameter where each of works in the different cylinder, right? So here A option is right option. Then move to the question number 7. Most commonly used hydraulic intensifier for water jet cutting is inline hydraulic intensifier, parallel hydraulic intensifier, pressed hydraulic intensifier, casting hydraulic intensifier. So the correct is here A option is correct. This is the inline hydraulic intensifier. Then move to the question number 8. A is a cyclic water pump that drives its power So 4 option is given here. First one is hydraulic crane, hydraulic ram, C is hydraulic accumulator, D is hydraulic presses. So correct answer is here hydraulic ram. Then move to the question number 9. The cylinder with a smaller diameter is called the sleeve cylinder, and bigger diameter of the cylinder called the master cylinder. So the answer is here A is the correct answer for this question. And the question number 10. This is the last question of this lecture. Is the main essence of the car crushing system: hydraulic press, hydraulic cylinder, hydraulic crane, and accumulator. So option A is right answer. A hydraulic press is the main essence of the car pressing system. And then more to the references of this chapter. And these are the different type of references. If you want more information about this lecture, then you will go to these books and follow these books for the more information about this chapter. And thank you all of you for the kindly listening and kindly watching this lecture. Thank you all of you. Thank you.